about this one, the original does not need to be alternating. It can or it cannot be, it doesn't matter. This is for any series, we can run this. Do you plan on being a math teacher, just in general?
No.
It's a great job.
Aww.
One of the pieces of advice that I would give anybody who wants to think about teaching, especially a field like this with math, is in a class, you have to give your students time to think. Some teachers, they just go up there and they just start talking and writing and they just go.
Yeah.
If you want there to be learning to happen in the classroom, you have to stop and give them time to think.
That's why you're a great professor.
So, what I mean by that is, and there's a balance between I have to wait and let some of the quicker people be a little bored, and I have to let some of the people that are not as quick, give them, I may have to cut them off or something like that. A class this size is a nightmare. Because I got people totally opposite ends of the spectrum here. So some of you think I'm going way too fast, some of you think I'm going way too slow. I'm trying to stick in the middle here. Let's talk about the ratio test. Ratio test says if I do a comparison between the two, meaning I have the next term divided by the current term, the nth term, and I run a limit as n goes off to infinity, and I take the absolute value, if I get a limit and it's less than 1, technically it's going to be between 0 and 1, right? 0 is okay. I cannot take the absolute value and come up with a limit that's going to be negative. You would agree?
Right.
Alright. If that limit is less than 1, then we can stop and just say it's absolutely convergent, which is therefore convergent. The flip side of that is if that same limit goes to something higher than 1, including infinity, any number or craziness that's bigger than 1, right away we say it's divergent. If that limit goes to 1, it's probably conditionally convergent. We can't make any conclusions with this test. You got to try something else. Fair enough? Alright. Let's run this test. This is going to require some algebra that's a little crazy. You'll catch on to it after a while, but running this limit sometimes can get a little weird. Got it back. We can actually run the root test on this one as well. Alright. So we have the summation as n goes from 1 to infinity of negative 1 to the n, it's alternating. And then n over 3 to the n. Let's walk through our tests. Let's come up with our options. Is this a geometric series test? No. No. If it's alternating, no. That's not true. But this is not. Is it telescoping? No. Test for divergence, I could run that limit, and for sure, after I run that limit, we're going to end up that limit goes to 0. Which tells us what about the test for divergence? It's inconclusive. Next up, we have the integral test. I don't want to integrate that. That's a mess. Okay, that's horrendous. In fact, if I did the integral test, in fact, I can't do the integral test because it's alternating. I could take a shot, take the absolute value, and hope for the best. Even then, that integral is not going to be nice. In fact, they may not even have an antiderivative. It's not P series. We're sure. Direct comparison or limit comparison, I might be able to find something that it would be comparable to. That would take a lot of extra thinking on my part. And even then, it would be a guess. I'd run it, and possibly, if I do limit comparison, the limit goes off to infinity or something. Oh, bad comparison, try something else. It is alternating series. We could try it out. It's hard to tell if that particular function is decreasing or not. It might be. Like I think it is. I'd have to do the derivative, and the derivative of, no, I don't want to do that. Right? That's ugly. But you could, make the alternating series. We could take the absolute value and try something, but I don't see anything that's going to help out, which brings us to the ratio test. So you can go through the list. You can just walk through. So when you do the project, don't rule anything out. Often, some of the problems is here. You can look, the limit's not 0, you're done. There's like no work to do. So we're going to try the ratio test. Here's my a sub nth term.
N over 3.
I also need my a sub n plus 1 term. What that means is I'm going to increase I'm going to change all of the n's here to n plus 1. You know who told me I need to give them time to think? My wife.
Yeah.
She was a student of mine. She's like, you got to give us time to think. So we have our two terms, right? Our n plus 1 term and our nth term.
She is my student.
Yes? That's why I raised it. Now, you're never going to see me write it like this again. I'm going to play with some algebra before I do anything. First of all, I'm doing the absolute value, so that -1 to the n is ridiculous at this point. Right? Because we're doing absolute value, they're all going to be positive anyway. So when I set up the ratio from now on, you're never going to see me put the -1 in there again. If I don't do it the first time, the people flip out. So there it is. Next up, you would agree that if I'm dividing by a fraction, that's the same thing as multiplying by its reciprocal. So from now on, I'm just going to multiply by the reciprocal at the bottom. Okay?
We're skipping steps.
So my first step from now on will look like this.
Such a great lecture video.
This is terrifying. This is manageable. I've broken down teaching way too much. As you guys are covering this, I call this the gopher stage. This is the... I think way too much about it. All right. I'm going to do a little algebra. I'm going to remember a rule that you learned in pre-algebra. Remember that? I'm going to use it backwards. To the 3 to the n plus 1. what happens to the 3 to the ends? Reduce.
Mm-hmm. See your squiggles.
All right, I'm going to apply some magic here.
I'm afraid of roller coasters, so I'm voting this
Is the 1/3 affected by the limit?
in. No,
I need a little bit.
you know, we put the one student, just
You just pulled that out, right? Yeah. So,
you know, how we broke
Forget the 1/3 for a second. Where does this limit go?
1.
It goes to 1, right? Lead coefficients? The degree's the same, therefore the lead coefficients take over, 1/1. You can also break this up into 1 plus 1/n. You still get 1. So all of this becomes 1. So what's the limit?
1/3.
1/3.
Yeah, because it'll be plus. Essentially.
Okay. We ran the limit, we got an L. What is L in this case?
1/3.
1/3, it's less than 1. That's the big thing. If that's less than 1, then what's our conclusion? It's absolutely convergent. You with me? After you finish copying this down, I want you to put your pen and pencil down. I want you to just talk it over with someone.